Dr. R.K. Radha, Assistant Professor, Department of Statistics, Presidency College, Chennai. She has done her PhD in statistics on a novel approach for prior selection in Bayesian modeling. She has 27 years of teaching experience, has guided 4 MPhil students, published 5 articles in national and international journals, has attended 10 conferences in India. She had given training for staff at Tamil Nadu State Statistical Training Institute, Department of Economics and Statistics.
Welcome to UGC lecture series on mathematical sciences. In today's class, we are going to discuss confidence interval for difference between means under the case when sigma is known and sigma is unknown. Let x1 and x2 be the random variables having normal population, normal with mean mu1 and variance sigma squared, and normal with mean mu2 and variance sigma squared. Let x1 bar and x2 bar be the means of the sample of sciences n1 and n2 respectively taken from these two normal populations. So, case 1, we are going to discuss if the variances are known. Then we know that the sampling distribution of x1 and x2 is also normal, and it is given by normal with mean mu1 and variance sigma squared by n1. Similarly, for x2 bar, it follows normal with mean mu2 and variance sigma 2 squared by n2. Since x1 and x2 are independent, the distribution of x1 bar minus x2 bar also is normal with mean mu1 and mu2. Variance is going to be sigma 1 squared by n1 plus sigma 2 squared by n2. Therefore, let us see what happens to the distribution of x1 bar minus x2 bar minus of mu1 minus mu2 divided by square root of sigma 1 squared by n1 plus sigma 2 squared by n2. This distribution is nothing but normal mean variance, mean 0 and variance 1. So, let us assume that ZB equal to x1 bar minus x2 bar minus mu1 minus mu2 divided by square root of sigma 1 squared by n1 plus sigma 2 squared by n2. By the definition of confidence interval, we know that 100 into 1 minus alpha % confidence interval is given by probability of minus z alpha by 2 less than or equal to z is less than or equal to z alpha by 2, which is equal to 1 minus alpha. So, here in the place of z, we are going to substitute the z value. Therefore, you will have probability of minus z alpha by 2 less than or equal to x1 bar minus x2 bar minus of mu1 minus mu2 divided by square root of sigma 1 squared by n1 plus sigma 2 squared by n2 less than or equal to z alpha by 2, which is equal to 1 minus alpha. Now, divide or multiply on either side by square root of sigma 1 squared by n1 plus sigma 2 squared by n2. So, when you multiply on either side, you will have minus z alpha by 2 sigma 1 squared by n1 plus sigma 2 squared by n2, which is less than or equal to x1 bar minus x2 bar minus of mu1 minus mu2 less than or equal to z alpha by 2 into square root of sigma 1 squared by n1 plus sigma 2 squared by n2, which is equal to 1 minus alpha. Now, we are going to do certain operations, namely that on either side we are going to subtract x1 bar minus x2 bar. So, this equation will reduce to probability of minus of x1 bar minus x2 bar minus of z alpha by 2 into square root of sigma 1 squared by n1 plus sigma 2 squared by n2 less than or equal to minus of mu1 minus mu2 less than or equal to minus x1 bar minus x2 bar plus z alpha by 2 into square root of sigma 1 squared by n1 plus sigma 2 squared by n2, which is equal to 1 minus alpha. Now, our objective is to find out what is the confidence interval for mu1 minus mu2. Therefore, I multiply either side by minus 1. So, you should remember that when you multiply the inequality by minus 1, the inequality gets reversed. Therefore, you will have x1 bar minus x2 bar plus z alpha by 2 into square root of sigma 1 squared by n1 plus sigma 2 squared by n2, which is greater than or equal to mu1 minus mu2, which is greater than or equal to x1 bar minus x2 bar minus of z alpha by 2 square root of sigma 1 squared by n1 plus sigma 2 squared by n2, which is equal to 1 minus alpha. Therefore, on rearranging the whole process, you will get probability of x1 bar minus x2 bar minus z alpha by 2 into square root of sigma 1 square plus n2 will be less than or equal to mu1 minus mu2 less than or equal to x1 bar minus x2 bar minus of z alpha by 2 into square root of sigma 1 squared by n1 plus sigma 2 squared by n2, which is equal to 1 minus alpha. Therefore, 100 into 1 minus alpha % confidence interval for mu1 minus mu2 is nothing but x1 bar minus x2 bar minus z alpha by 2 into square root of sigma 1 squared by n1 plus sigma 2 squared by n2, comma x1 bar minus x2 bar plus z alpha by 2 into square root of sigma 1 squared by n1 plus sigma 2 squared by n2. In other words, if you want to write it in the form of confidence limit, it can be written as x1 bar minus x2 bar plus or minus z alpha by 2 into square root of sigma 1 squared by n1 plus sigma 2 squared by n2. So, this is going to be 100 into 1 minus alpha % confidence interval for mu1 minus mu2. So, next we are going to discuss the second case when the variance of the two populations are unknown. If it is unknown, then we have to find out a case where the sample size is going to be small. So, here therefore, the statistics is going to be if sigma 1 and sigma squared are unknown, not known. If it is unknown, then your statistics becomes t is equal to x1 bar minus x2 bar minus of mu1 minus mu2 divided by sigma cap into square root of 1 by n1 plus 1 by n2 follows t with n1 plus n2 minus degrees of freedom. Now, what is this sigma? Sigma is nothing but sigma cap squared is equal to n1 minus 1 into sigma 1 cap squared plus n2 minus 1 sigma 2 squared divided by n1 plus n2 minus n2, where in turn sigma 1 squared and sigma squared can be calculated by using summation of xi minus xi bar the whole square divided by n minus 1, where xi can be either for the first sample or for the second sample. Now, once again consider 100 into 1 minus alpha % confidence interval for the case of difference in mean when the variance is unknown. Therefore, it becomes minus t alpha by 2 less than or equal to t is less than or equal to t alpha by 2, which is equal to alpha. So, here substitute the value of t in this particular equation. Here if you substitute, it becomes probability of minus t alpha by 2 less than or equal to x1 bar minus x2 bar minus of mu1 minus mu2 divided by sigma cap into square root of 1 by n1 plus 1 by n2 less than or equal to t alpha by 2, which is equal to 1 minus alpha. Now, as before, multiply either side by sigma cap into 1 by n1 plus n2. So, the equation reduces to minus t alpha by 2 sigma cap 1 by n1 n2 and less than or equal to x1 bar minus x2 bar minus of mu1 minus mu2 less than or equal to t alpha by 2 into sigma cap 1 by n1 plus 1 by n2, which is equal to 1 minus alpha. Now, the next step we are going to perform is that multiply the previous equation by subtracting this equation by x1 bar minus x2 bar. The equation reduces to minus of x1 bar minus x2 bar minus t alpha by 2 into sigma cap of square root of 1 by n1 plus 1 by n2, which is less than or equal to minus of mu1 minus mu2, which is less than or equal to minus of x1 bar minus x2 bar plus t alpha by 2 into sigma cap of square root of 1 by n1 plus 1 by 2, which is equal to 1 minus alpha. So, here the next step is that multiply either side by minus 1. This whole equation you multiply by minus 1. Therefore, the inequality gets reversed. Therefore, it becomes probability of x1 bar minus x2 bar plus t alpha by 2 sigma cap into square root of 1 by n1 plus 1 by n2. It becomes greater than mu1 minus mu2, which is greater than x1 bar minus x2 bar minus t alpha by 2 sigma cap into square root of 1 by n1 plus 1 by n2, which is equal to 1 minus alpha. Now, rearranging this whole term, we will have probability of x1 minus x2 bar plus t alpha by 2 sigma cap into square root of 1 by n1 plus 1 by 2, which is less than or equal to mu1 minus mu2 less than or equal to x1 bar minus x2 bar plus t alpha by 2 sigma cap into square root of 1 by n1 plus 1 by n2, which is equal to 1 minus alpha. Therefore, 100 into 1 minus alpha % confidence interval for difference in mean when your variances is unknown. Therefore, that is x1 bar minus x2 bar minus t alpha by 2 sigma cap into square root of 1 by n1 plus 1 by n2 comma x1 bar minus x2 bar plus t alpha by 2 sigma cap into square root of 1 by n1 plus 1 by n2, or if you want in the limit form, it is going to be x1 bar minus x2 bar plus or minus t alpha by 2 sigma cap into 1 by n1 plus 1 by n2. So, square root of this. So, this will give you your confidence limit. Now, we have got an important note is that if the population standard deviation of sigma 1 and sigma 2 are not known, then we can take S1 and S2, the sample standard deviation, as the best estimate of sigma 1 and sigma 2 if the sample size are large. Now, let us go for a simple example. So, consider this particular problem. Electric bulbs manufactured by X and Y companies gave the following results. So, two companies are there, X company and Y company. Number of bulbs used is 100 and 100, and mean life in hours for X company is 1300 and that of Y company is 1248. Standard deviation in hours is given as 82 and that for Y it is 93. You have to obtain 95% confidence limit for difference in mean life of the two makes. So, how to go about the problem? So, here it is the confidence interval for the mean life of the two makes. Therefore, you have to find out 100 into 1 minus alpha % confidence interval for the difference in mean mu1 minus mu2. Therefore, your required formula is going to be x1 bar minus x2 bar minus z alpha by 2 into square root of sigma 1 squared by n1 plus sigma 2 squared by n2, comma x1 bar minus x2 bar plus z alpha by 2 into square root of sigma 1 squared by n1 plus sigma 2 squared by n2. From the given problem, you have got your sample size is 100 and 100 for both the companies. So, it is a large sample. X1 bar is given to be as, that is a mean life, x1 bar is 1300 and that for the second sample it is 1248. Standard deviation is also given. So, standard deviation is 82 and for the second sample it is 93. So, we are going to substitute all these things in the required formula. Apart from that, from normal tables, we have to find out what is the value of z alpha by 2. Here it is, we are going to find out 95% confidence interval. Therefore, 1 minus alpha, 100 into 1 minus alpha will become 0.95. Therefore, from here alpha is equal to 0.05. When you look into the normal tables at 5% level of significance for two-tailed test, it is going to be 1.96. Now, substituting all these values, that is your table value x1 bar, x2 bar, sigma 1 squared by sigma 1 squared, sigma 2 squared, n1 and n2. the given equations will take this particular form, that is 1300 minus 1248, namely your x1 bar and this is x2 bar minus of, this is going to be the table value, here it is the standard deviation, and this is going to be your standard deviation for the second sample. So when you take, it becomes a variance 93 squared. So similarly 1300 minus 1248, here it is going to be plus 1.96 into sigma 1 squared by 100 plus sigma 2 squared by 100. On simplifying, you will get x1 bar minus x2 bar is 52, table value is 1.96, and here sigma 1 squared by n1 is 67.24, sigma 2 squared by n2 is nothing but 86.59. So here it is similar manner, difference in mean plus table value into your standard deviation value. So on proceeding in this particular manner, that is adding and taking the square root, you will get 12.398. Here also 67.24 plus 86.4 gives you 12.398. Next, you multiply these two particular term, 1.96 into 12.39 amounts to 24.30163, and next here you do the operation as 52 minus this amounts to 27.6984. Here it is 52 plus 24.30 will give you 76.3016. Therefore, your 95% confidence interval for difference in mean life of two makes is given as 27.6984, 76.3016. So next we will go to the example 2. Here the marks obtained by a group of 9 regular course students and another group of 11 part-time course students in a test is given below. So regular students is given and part-time. You have to obtain 95% confidence interval for difference between the marks obtained by regular and part-time students. Here you have to remember that sample size is small, and here two raw data is given to you. You need to find out your variance. So here step 1, I am going to find out mean and variance. So here I have got the values of x. So I am taking the deviation about 60. Therefore 56 minus 60 will amount to minus 4. Similarly 62 minus 60 is 2, 63 minus 60 is 3, 54 minus 60 is going to be minus 6. Proceeding in this similar manner, you can fill in this particular column, and when you sum up, you will get the value to be equal to 0. Squaring D1. So it is going to be minus 4 into minus 4 is 16, 2 squared is 4, 3 squared is 9, 6 squared is 36. So proceeding in this similar manner, you find the total sum is going to be 280. Now take the values of y, take the deviations. So deviations I am taking here about 66, that is D2 is nothing but y minus 66. Therefore you will get here as minus 4, 70 minus 66 is 4, 71 minus 66 will become 5, and here 62 minus 66 will become minus 4. So proceeding this and adding up, you will get your deviation is 0. So the last column, you have to square D2, that is D2 squared. So here you will have minus 4 the whole squared, which is 16. Again 4 squared will become 16. Proceeding the similar manner for the remaining observations, you will find the total is equal to 334. Now therefore x bar is nothing but, you know that x bar is summation of x divided by n. So from the previous column, your summation of x is 540. Therefore it becomes 540 by number of observations is going to be 9 observations. So it is going to be 540 by 9, which is 60. Y bar is nothing but summation of y is 726. So you have got 11 observations, which is equal to 66. Already I have shown that D1 is nothing but my deviations. I have taken it as x minus 60. Here I have taken it as x minus 66 for y observation. Here D2 is for the y. Now you have to find out S1 squared. S1 squared is nothing but, it is nothing, summation of D1 squared by n minus of D bar, where my D bar is nothing but summation of D divided by n. So look into this particular thing. You have got your summation of D is 0. Therefore, it is going to be 0. So this term will be 0. D1 squared is 280. Therefore, here it is 280. You have substituted here. The number of observation is 9. Similarly, proceeding for the second sample, that is for the sample y, you will have 334 by 11 minus 0, which will be 334 by 11. In either case, whether it is D1 or D2, D1 bar and D2 bar is 0. Okay, therefore your S1 squared is 280 by 9, S2 squared is 334 by 11. Now you have to find out the combined variance. The combined variance is given by n1 S1 squared plus n2 S2 squared divided by n1 plus n2 minus 2. So here S1 squared is 280 by 9. Therefore, you have got the formula S1 squared is nothing but 280 by 9. This 9 is nothing but your n. Therefore, n S1 squared is equal to 280, where n is here n1 for the first sample. So here it becomes 280. Similarly, for the second sample it is 334. First sample size is 9, second sample size is 11, and when you subtract it from minus 2, you will have 18. So on dividing, you will get 34.11. So you actually want to find out the standard deviation, take the square root, you will have 5.84. Now step 2, you have to find out 100 into 1 minus alpha % confidence interval for difference between the mean, which is given by this particular formulae, that is x1 bar minus x2 bar minus t alpha by 2 sigma cap into square root of 1 by n1 plus 1 by n2 comma x1 bar minus x2 bar plus t alpha by 2 sigma cap into square root of 1 by n1 plus 1 by n2. Now we have to find out what is the table value of t alpha by 2. So we go and refer the t tables, that is t distribution. Therefore, the table value of t with 18 degrees of freedom. Why I have taken 18 degrees of freedom means n1 plus n2 minus 2. So here the sample size, here it is for the first sample is 9, n2, that is the size of the second sample is 11, minus 2 gives you 18. Therefore, my degrees of freedom at 1% level, I want to find out for 99%. So here at 1% level is 2.878. So which I can write it as t alpha by 2 with n1 plus n2 minus 2, which is your table value. So when you refer t tables, you will get the value as 2.78. 878. Now x1 bar we have found out as 60, x2 bar is also x2. Here x1 bar is nothing but my first sample, x2 bar is the second sample, in which case my sample is, here this is going to be my x2 and this is going to be my x1. Now sigma cap, that is my combined standard deviation which I found out is 5.84. I am substituting here, and here n1 is 9, n2 is going to be 11. So here on substituting, equation number 1 takes this required form. On further simplification, this is going to be minus 6, T alpha by 2 is nothing but 2.878, and here into 5.84 I have to take the square root of 1 by 9 plus 1 by 11. So the resulting term is going to be 2.78 into 5.84 into the square root term is going to be 0.449. So here on simplifying this particular term, you will have 7.554. So here minus 6 plus 7 will give you 1.554, minus 6 minus 7 will give you 13.44. Hence 99% confidence interval for difference between the mean is minus 13.55 and 1.54418. Therefore 99% confidence interval for difference in between the mean is minus 13.5544, 1.554418. So here in today's class we have learned confidence interval for difference between the two population mean when population standard deviation is known and unknown. If it is known, we have used the normal test. If it is unknown, we have used the t-test. Now few questions for you to answer. First one, give the confidence limit for the difference between the two population means. And the second question is, two independent random samples of sizes 10 and 15 from two independent normal populations have variance as 4 and 9, and with mean is found to be 48 and 46 respectively. Estimate with 99% confidence the difference between the two population means. Thank you.